today we'll go over a couple questions. We're going to go over the importance of the ANSI TIA standards, what they are, what a Cisco validated design or CVD is, what both RCDD and CCDA are and why they're important, as well as kind of the overarching question of why do I need a network design. So first thing is, and I'm gonna ask a couple questions to the audience as we go along here. So Blake, I do have a question for you. What I'd like to ask you, what are the ANSI TIA standards, or what do they stand for, and why they're important throughout a network?
Well, I appreciate you calling on me right out of the gate here. I don't know exactly what the acronym stands for, what the letters stand for, but I think that there are telecommunication standards, and they're important because they give direction for how different aspects of a network need to be set up in order for it to work properly. How'd I do?
Exactly. You're on the button there. So the acronym stands for ANSI, stands for American National Standards Institute, and TIA stands for the Telecommunications Industry Association. These are different aspects, like you said, different aspects of the network, how they interact with each other. The one example we have here on the slide is the TIA 568 wiring. So this gives direction for how the Ethernet cables are actually terminated on either end, and how the connections on devices are wired as well. This would be important across the network, because could you imagine what if every device on your network had a different wiring format? Every device was wired a little bit differently. If I went from a Yokogawa VFD to a Rockwell VFD, and they had different wiring, I'd have to re-terminate that wire, re-plug it in. If I ever changed out a switch on the network, I would potentially have to change out all that wiring, how it went into the switch, if they all had different wiring standards. So these governing bodies have come together for multiple different aspects of that network, from the physical pathways, grounding and bonding, building automation systems, all the way down to how those devices are plugged into the network. They've come up with the standards and the best practices of how to do that. So they've basically taken out the guesswork of how we put all these networks together. We'll move on to the next topic, which would be the importance of a Cisco validated design. And for this question, I'm gonna call upon John Haley and ask him if he knows, what is a Cisco validated design, and why is that important throughout a network?
Sure. Good morning. So Cisco validated design is kind of a guideline. So rather than having to reinvent the wheel every time that you're looking to do something from a network standpoint and hoping that it works, Rockwell and Cisco partnered together to come up with best practices using standards to put together different architectures for design that are then tested and validated for concept proof. And each of the designs has there's always a trade-off of pluses and minuses that you get with each type. And there's not one size that fits all. So there's a variety of different documents documenting all sorts of best practices and how to design different types of networks.
Absolutely, John. I couldn't have put it better myself. To John's point there, why reinvent the wheel? Why go in and start guessing of how you go through and implement portions of your network? How data traverses across the different network areas, how security is implemented, how remote access is implemented, how you go and put in wireless throughout your network when very smart people have already taken that guesswork out of it. So here we see the converged plant-wide Ethernet documentation and all the different aspects that tie into it. So in the middle there, we have the baseline document, and then all the ancillary supporting documents of how you implement different things, the CPWE resiliency, configuring wireless in converged plant-wide Ethernet, SIP security, how you would implement time sync across a converged plant-wide Ethernet. These best practices have already taken into account the standards that we talked about in the last section, have tied them to how you go through and implement and take into account those standards and implement them in the best practices way across your network. Next section we're going to hop into real quick.
Excuse me, Trevor. There's
Yep.
a question that came through. So Doug Hoffer asked, which style of cable termination, TIA 568A or TIA 568B, is most commonly used in industrial settings?
Yep, great question. It might seem a little bit backwards, but it's actually the TIA 568B. That's not just industrial settings. That is across all IT organizations. Why someone chose to use B instead of A as kind of the default standard, your answer is probably as good as mine on that one. But the vast majority of the time, a straight patch cable is going to be 568B. The good thing about devices nowadays is that they're actually smart enough to sense which wires are your transmit and receive. And so if something is connected with either you would, in older days, to connect computers, you'd use a crossover, what's called a crossover cable, where it's 568A on one side and 568B on the other side. So if something is switched somewhere, it is possible for those devices to actually still communicate over a cable that had been wired one side A and one side B. And the computer or the device will actually switch its Ethernet port on its own. But 99.9% of the time, it is going to be that 568B wiring. All right, so we talked about the CPWE documentation and the importance of a Cisco validated design. Let's go into our next topic real quick, which is what is an RCDD and CCDA, and why are they important in the design of a network? And for this one, I'm going to call upon Josh Dirksen to answer.
Yeah, so Trevor, thanks for calling on me. So I'm aware from my Cisco background, CCNA, Cisco Certified Network Associate, CCDA, Cisco Certified Design Associate, but I'm not as familiar on RCDD. I know that the Cisco world, they tend to use it to say that a person is qualified to put together a good network. But tell me more on the RCDD side.
Yep, absolutely. So the RCDD actually stands for Registered Communications Distributor or Distribution Designer. They take into account more of the physical side of a network design. So that's really what we have going on in this document, in this picture here. They take into account pathways throughout the network. They take into account how the grounding and bonding for that network should be, and then they take into account what they call MICE, the mechanical, ingress, climatic or chemical, and electromagnetic. So throughout different portions of your environment, office areas are going to be very, very low on all aspects. So that's why we see on the right-hand side levels of ones across the board, because there's very low mechanical, very low ingress or water or dust. It's a climate controlled environment, and there's very little electromagnetic interference. Then we go out into somewhere like the processing area, where it could be washed down, right? So you have potential for water ingress. You have a very humid environment. You have lots of drives, lots of cables, that high voltage cables that are going across the area that could implement or could introduce electromagnetic interference. So the RCDD is able to take into account all these different aspects of the network or of the physical area, and help design and recommend your best practices from the physical portions of that, what cables to use, 600 volt rated insulated cables. Do I need watertight connectors? Do I need watertight cabinets? Things like that. CCDA, Josh, like you said, is Cisco Certified Design Associate. They take more into account the logical aspect of the network. So things like the IP addressing scheme across the system. If you have different areas that are in different networks, how the routing happens between those. If you need redundancy, what redundancy protocols are going to be best suited for that environment, and then things like wireless. If you wanted to implement wireless across your plant floor to allow for things like tablet mobility, things like that, they'll take into account how logically those requirements play into the network design. So moving on to the last section, kind of the big question: why do I need a network design? And for this one, I'm gonna call on Billy real quick and ask him a question. Billy, I know you've helped put together Ethernet networks in the past. Quick question for you on that though: how did you handle segmentation within those networks?
So typically when we build out segmentation on the networks, we'd usually just do it as a flat network so we could get on and just reach anything from any node in the network. Maybe I'm in the packaging area and there's a problem over in the mixing. I might need to get on right there and be able to reach it, or I just want to touch everything from my desk.
Yep, absolutely. And typically that's how it's been done in the past, right? Everything's on one big flat network. You used unmanaged switches and everything kind of worked for a while, but then at some point it's just going to stop working, right? Because there's going to be so much traffic on the network. Things like controllers have a limited amount of bandwidth to be able to process the amount of traffic that's actually on that network. So with the multitude of devices that are becoming Ethernet enabled from the factory, we need to take that into account. One example that I'd like to bring up is application-specific segmentation, and that really plays into this blue area of the diagram we have here, the cell area zones of your network. So normally in a network you have, or in a large-scale control system, you have your site-wide, your supervisory network SCADA systems, and then you have your control systems that are down on machine level. So example that I like to give is the end user that I came from. We had packaging area, processing, filling, packaging area, and then the control room that kind of controlled everything, the major processes throughout the system. We had network segmentation, so servers were on their own network, wired clients were on their network, printers, things like that. Typically in the IT world, everything is split up into its different areas. If anything is a device that's of like type, is usually on its network with other devices that are the same. In the controls area, though, on the plant floor, you can't quite do that. You can to a point. Servers, yes. Supervisory HMIs, yes, you can do that, where they can all be on their own network, their own segmented network. But when you get down to the cell area zone, or to the individual processes, they need to be all connected together. And the example would be, if here in the middle I have a distribution switch right at the boundary of the green and blue areas, that switch would be handling the routing between all the different cell area zones. If that switch goes down, I've now lost supervisory control for the entire system. But each cell area zone is connected within its own network. So even though they're of different device types, HMIs, servos, IO, instrumentation, things like that, they're all within the same network. They can all natively talk to each other. So if that distribution switch goes down, I may not be able to control it from the control room, but I can go out to the HMI that's on that line, on that process, and I can either start, stop, continue operations of my system while we go in and repair or fix that distribution switch. So the final answer to, why do I need a design? Why is it important? Well, it's important because of the unknowns throughout the entire process, right? From physical to logical, there can be so many different little gotchas that can come up if you're not aware of it. From grounding and bonding and how that interfere or could potentially impact the switches throughout the networks, to routing and segmentation. There are just so many different aspects that need to be put together and thought of in the proper ways, and they're very easy to overlook when they're really things that cannot be overlooked. So there's people out there that have these certifications, that have the knowledge and know-how that have that can take from the standards all the way up to the physical aspect of the network, how it's ran, how cables are run through the network, how where cabinets need to be placed for ease of access, things like that. They're able to take into account all those different small aspects of that design and put together a well thought out, well developed system. So Zita, with that, I will turn it back over to you.
Thank you, Trevor. So before we move on, does anyone in the audience have any questions for Trevor? Feel free to chime in with any, plant floor specific questions that you may have regarding your network. Don't speak all at once now. Okay, so I'm going to take that as a no. So I just want to remind everyone that this recording will be placed in our Rexel Delivered Services YouTube Tech Talk channel. Once this is completed, we will send you that link. So if there's a counterpart that you wish to share this information with, particularly on your IT side, please feel free to do so. So in terms of what Trevor just said, we can have, there are multiple avenues that now we can pursue with you. So with his expertise and the resources that we have with Rockwell and internally, if you like, we can support you with a 15-minute exploratory discussion on what your current network looks like today. Maybe you don't need a full-blown network design, but you do need some assistance with troubleshooting or maybe addressing a particular area or process. And if you feel that a network design is something that you absolutely need to find out if you need more information on, we're happy to come on site and conduct a walkthrough of your facility. That way we can evaluate, what your best option is or what the best next step for your plant floor is. I will be forwarding out and reaching out to everyone on the call with my contact information and just getting your overall feedback on today's presentation. So with that, if there aren't any questions, we can end the presentation. Thank you guys for attending.